I'm back. My name is Jeferson Costa. I'm a chemical process engineer with expertise in plant design, and welcome to the Chemical Process Engineer Diary. It is where I share with you my daily life as a chemical process engineer working with plant design. I answer questions, do the clarifications about everything or almost everything that I know about chemical process engineering and plant design. And today I'm doing a test. I am transmitting or I am doing the streaming of this live session of this series in Instagram at my left side and also in my YouTube channel. And I'm doing that to verify where people like to talk with me. What is good about Instagram is that I can invite people to be live with me. I'm not able to do that in YouTube, but I have observed that many of my followers, my students, and people that are interested in chemical process engineering in plant design are in YouTube. So to start with the series today, let me talk a little bit about what was the main activities that I did yesterday as a chemical process engineer working with plant design. I start my day at 9 a.m. here in Brazil, and most often I have an engineering meeting with the department. So I am not the leader of this meeting. I have the Bruno Raj that are responsible for leading this meeting, and we discuss issues related to our project. So this way, it's in an important meeting because the team gets aware of what's happening, what are the kind of issue that we must face, and with this we get not only aware, but we can help our colleagues, our comrades to proceed with the project and anticipate what are the challenges that we need to finish our job. And after that, I had another meeting, and this time to talk about some issues that are happening in the operations, and I need to analyze the behavior of the pressure, because we have a source of raw material that is supposed to be available at. Hi, Hutik, nice to have you here. And I have a raw material, an interesting thing to when we are analyzing a source or a feed, we have I'm dealing with a well from onshore site, and there are two kinds of pressure that you should verify or that you should evaluate in order to do a project. The first thing is that when the well is not producing, we are not removing gas from the well or from onshore. What happens is that the pressure of the onshore is at the static pressure of the system. So it will, once there is no flow, the pressure will equilibrate with what is inside of the onshore well. However, when we start producing, we get fluids from the well, and now we are having some kind of transportation and fluid flow, and the pressure will not more, it will be not more the static pressure, it will be dynamic pressure. And why it is very, very important to you understand these two kinds of concepts. It is because when we design a system that is receiving this feed gas, what will drive the operation pressure is the dynamic pressure, because the dynamic pressure considers the pressure drop through the pipeline, the temperature, and the condensation of condensates that you can have in the stream, and etc. However, when we stop our production, there will be a peak of pressure that will calibrate the system with the static pressure. And just to give you an example, in this case, my well has a static pressure around 25 bar G. So my pipeline must be able to handle this kind of pressure rating. But when I'm producing, and of course that depends on how much gas I'm taking from the well, because as much gas I remove, I withdraw, more will be the pressure drop and lower will be the operation pressure. So in this case, currently the dynamic pressure is around 15 bar G, and you see that there is a great gap between the static and the operation pressure. And if I'm planning to install a dehydrator equipment, and if I inform to the supplier that my operation pressure is 25 bar G, the calculations and the size of the equipment will be totally wrong, because in fact this equipment will operate at 15 bar G. However, if I not consider the static pressure, when I stop the production for any reason, can be operational reason, safety reason, the pressure will go up to 25 bar G. And I want that my system is designed in a way that I don't open any kind of PSV, because the 25 bar G, it's already expected in my system. So in this way, I have concerns related to operations conditions, and it is most often how you will design your equipment in terms of performance, but you must evaluate also and consider the static pressure, because that will impact the maximum allowable working pressure of the system and the pressure rating of your pipelines and etc. So that it's something that I would like to share with you. Okay, guys? And moreover, there was an incident in one of our installations, and the customer is not very happy with us. And every time that some kind of incident or accident happens in an industrial facility, it is very important that we look for the root cause. And this way, in this case, we do a meeting with a multidisciplinary team in order to evaluate what happened, what was the issue, what was the probably cause of the issue, and what are the action plan to solve that, and don't let that happen anymore. And in this case, there was a fail in a pressure transmitter, and we delivering some gas for the customer. And in a case of high alarm in the pressure transmitter, what happens is that we need to cut off the source of pressure. In this case, is the product that we deliver for the customer. And but we have many lines in parallel. We have different stations in parallel. So eventually, if we cut one, we could be able to supply the customer with another line. But the logic was written in a way that it was not possible. So because of that, we are discussing, and people gives idea in order to us evaluate what is happening. Okay, so this kind of meeting usually is not short. We take many times to evaluate and to propose solutions. Just for reference for you, we evaluate only one event, and I set the meeting for 2 hours, but we expanded 3 hours, and we didn't finish that. Today morning, 11 a.m. here in Brazil, we will return to this meeting in order to conclude the report. And we always need to do a report, because that way we will have the track of what happened, what was analyzed, and with this comply with the action plan. So this is the main activities that I would like to share with you today that I did yesterday. And I have some questions that I received in my LinkedIn profile. And it's very nice. There is some Brazilian guys that shared questions with me. It's not so common, so let me share with you the questions that I received, and this was from Mateus de Sá. And what he asked me was that he has a concern, and it is very, very common concern because I had the same kind of thought when I was finishing my graduation. He wants to know what if it is possible to develop a good engineering skills, not having experience in the industry or not having an opportunity to do a trainee in a company. And in Brazil, I don't know in other countries, to finish our graduation in chemical engineering, we need to have some kind of trainee or minimal time of hours working as a trainee in a company. And of course, that when we are studying, we want to have this kind of trainee in BASF, in Bayer, in oh, there are so many companies, and I forgot names. Okay, Exxon and etc. But not everyone are able to get opportunities on those companies, and eventually we find small jobs to do in order to comply with the minimum requirements hour. And it was my case. Okay, I was never so good in interviews, and I still am very shy, and I didn't get opportunity to work in a big company during my graduation. But I was an employee of a municipal drugstore, and I had some connections, so I got an opportunity to do a trainee in a water treatment facility. So mainly what I did is observe the analytical results of the water, and what only that it was around 1 to 2 hours per day and 2 days per week. And with that, I was able to fill the requirements hours that I needed to finish my graduation. And today, it was in 2005, 2004, or more like that. And today I'm here with you, and I can tell you that I may not be, for sure, I am the best chemical process engineer in the world, but I have a lot of things to share with people, and I have many students that are helping, so I can say that I have a good experience, or I am at least a good chemical process engineer. So if you don't have the opportunity during graduation, it will not define your future as a chemical process engineer. What will define that is the things that I shared with you in the last live session in my YouTube channel. So if you go there, you will see that I did 1 hour and 30 minutes video talking about what is my considerations about to be a chemical process engineer, a good chemical process engineer, and how to build your career based on that. And you need to know the fundamentals, you need to improve in your personal development, and you need to add energy for marketing, okay, or social skills. So this is the summary of the video, and you'll get more details on that. And I have a question from Assad. What are best traits of process chemical engineer? Best traits. Please, Assad, clarify to me what do you mean by best traits, in order that I can answer your question, okay? So this was I will answer you, Assad, as you clarify. So Mateus, this is my answer for you. Don't give up from your dream. What you need to do is focus on what really matters to your career. So my tip is choose a field to get more knowledge about that. And if you want to work with plan design, you have a set of skills that you need if you want to work with research and development. There is another set of skills that you need, and this and etc. So this is the way. Means that it okay, about skills and personality. Okay. In my point of view, okay, guys, just to summarize what was said in the live session, is that you must invest in your technical skills, and it is not it's the everyone that do chemical process engineer know about that. It's a knowledge, let's say something like this. But only that is not enough to you get to you connect with people, to you be able to share your thoughts and sell your ideas, because what we do every day is selling our ideas when we are discussing, when we are talking with people in order to get a job position, for instance. So what I recommend you is that you strengthen the fundamentals of chemical process engineering, that is fluid flow, rotating equipment, heating equipment, and you look for some kind of personal development. It's very, very important. There are many good authors out there. I personally follow Tony Robbins and Bob Proctor. And you must also invest your energy in social skills. And to talk about three of them, you have to improve your oratory. My oratory is not the best one, but every day it gets better than yesterday, at least at my point of view. You need to put energy in marketing, because it's very, very important to know how you emphasize the information that is important to your customer. And in this, the customer can be the followers in your LinkedIn profile, can be the interviewer in your job interview, can be your boss if you are already working. So if you understand how is the mind process, it will help you a lot to comply with the wishes of the people. And the third one is about selling. Marketing is how you show the product that you have, and selling is how you close the deal. So they are, although they are interrelated, it's not the same thing. So that's why I recommend you to build your career, okay, guys? And as I told you, there are many more resources in my YouTube channel talking about it. And I received a question in YouTube, and not more skills, okay? So here I have a message for Deepak Paul. My advice: diversify in first 10 years and then concentrate. Focus in the next 10 years on naturally good at. It is an interesting advice, and I do not disagree about that. And when we finish our graduation, what we must want is get any kind of job, okay? Because we need to support our family, we need to show that we are worth. But my point of view is that when we concentrate our energy in one point, imagine that we have a target, a cycle. Imagine that we have a target, and as we know, the target has, let's suppose that it is the job market, okay? And we have a target, and we concentrate all our energy to get the target. If I throw my arrow to get the target, eventually my arrow will get here, will get here, will get here, but it will much closer to the target than if I don't aim anything and my arrow will get here, will get here, will get here, will get here. So this is my point of view, and the world is getting more and more competitive. So if you focus your strength and energy in one goal, eventually others opportunity will appear in your path, and you can evaluate if it's worth or not to get those kind of experience, because some kind of experience is better than any kind of experience. Okay, but if you don't know where you want to reach, the things will be much harder. So I have some other comments here in my YouTube. Let's see. How to get first chemical engineering job in today's time. And yes, I talk a little bit about it in my live session, and I recommend you to take a look on that, because Deepak, keep the company of good process engineer and learn from the experience like Vijay Sarat, Jeferson Costa, initial years. Try having a mentor. Yes, this is very important. You have many ways to learn things, and of course you can learn from books, you can learn from YouTube, and you can learn from people and in the presence of people. So when you have a reference to build your knowledge, it's very interesting. Guys, my cell phone in Instagram, it's already alerted me about the low battery. Okay, so if it closes, it's because the low battery. So let me answer another question that I received in my LinkedIn profile, and you are free to send me questions in LinkedIn. I will answer as soon as possible. And the question was about compressors. So it was from Hussein Malikli. And so I hope you are doing very well. I want to ask, are there any approved standards like GPSA, API, ISMA, and others for choosing multi-stage compressor instead of single stage one? Based on which criteria we have to choose multi-stage compressor? I look forward to seeing your feedback. So to answer this question, I have a complete, I have a 45 minutes talking about reviewing the compressor equipment. But to answer this question is I don't know any standards that address how to choose one stage or multi-stage compressor. Okay, I'm not so sure if it exists in one, because the numbers of stages depending on the mechanic depend of many things, and one of those things is the pressure that is upstream of the equipment and the pressure that is downstream of the equipment. How bigger is this differential pressure, more stages of compression you need, because every time that we compress a gas, it increases its temperature, and the temperature, there is a limit to not damage the materials, to not damage the sealing of the equipment. So to bring back the gas to the initial temperature, or at least closer to that, the machines has the intercoolers or heat exchangers to cool down the gas, and eventually there are some kinds of some compressors that there is a casing, water casing, to cool down the head of the equipment, and with that you can decrease the numbers of stages to get the differential pressure. Okay, so most often, and in this class that I talk to you, that is available in my YouTube, there is a chart showing the typical ranges of flow and differential pressure, and which kind of compressors must apply to that kind of range. So if we are talking about bigger flows and intermediate pressure, intermediate differential pressure, eventually what best fits for that, and what best fits is not only a matter of equipment and itself, it's a matter of cost benefits, because you want to compress the highest amount of flow to the pressure drop that you want to, with the lowest consumption of energy. So the tip is this: when we are looking for equipment, we want the lowest energy consumption. So based on that, you can drive your energy to the suppliers that comply with those kind of requirements. And that is very important, because if you buy the chart and it is a generic chart, and you see that the best one, the compressor that best fits for that kind of process is a reciprocating compressor with a multi-stage, you will not expend your energy with a supplier that are only able to offer you a centrifugal compressor with one stage only. Okay, so it is more about markets and the markets and the vendors than about standards. The standards, you will verify what is the maximum temperature that the gas can reach, what are the requirements of safety, of materials, and etc. But the technology, who develops the technology is the market and not the standards, okay? So this is it. And guys, do you have any question? Please let me know. I am almost 30 minutes here, and it's very, very nice to be with you. Let me see if I have some other questions in my YouTube channel. Sorry, I have other questions in my LinkedIn profile. Let me look for another one. I have here a question from Phan Quang Viet, and he is from Vietnam. I don't see too many people from Vietnam, and it is very, very nice to know that I reach Vietnam. And my name is Viet from Vietnam. I'm project engineer, but have a little time for process engineering. Can you advise for literature or theory experience for design observer tower? Yes, I can, and I already did that sometimes in my YouTube channel and also in the blog in my website, jeffersoncosta.com. And in my website, I listed 3 or 5 books that I recommend you if you want to get more experience. You improve your technical skills in plan design. And one of them is the chemical process engineer. I will not remember the titles by head, okay? Sorry, by mind. But you can take a look on that. What I recommend today for people that are interested in processing of gas processing is the GPSA electronic data book. For me, currently, it is the best one of all, because there you have not only the theory, but you have also examples on how you do the verification of the calculations and etc. So this is the top one for me, okay? The GPSA electronic data book. If you want to know more references, you can go to my website, jeffersoncosta.com, and in the search bar, you can type books. There you will find this post with 3 books to boost your technical skills in chemical process engineering. And I have another video here in YouTube that suggests you some magazines, and magazines is a very good source of information when we are talking about plan design, okay? Because we get familiar not with the latest news from the industry, but also about the vendors and the suppliers, and that is very, very important when we are doing plan design, because as I always told you, for you, is we chemical process engineers in plan design, we don't reinvent the wheel. We get what is already available in the industry, and we apply that, and we adapt that to our needs. So this is what I do. I don't design, I don't create a new pump. I got the requirements that my system needs, and I look for the markets to Sundyne, to KSB, and to Growth, and look for what is the best pump that fits for my needs with the lower power consumption. And lower power consumption and best efficiency. It is what we always are looking for. And the compressors is the same, and there are some equipments that is very specific for a chiller, for instance. You will not design a chiller if you are outside of a chiller company. So this is what I suggest you in terms of literature or reference. Okay, guys? And I will close for today. I need to prepare some technical specification, and in some minutes, in fact, in 1 hour, I will start my working day officially here in Brazil. Nice to have you here, and if you want to know more about chemical process engineering plan design, I recommend you to go to my website, because there is a free training that is available to you with more than 7 hours to talk to you about what are the roles and responsibilities of the chemical process engineer in plan design. So, bye-bye.